Alright, two more examples of equations involving algebraic fractions. These come from the textbook 2.6 worked example 15. Here's our first example. What I'm going to do first of all is put the 4 over 1. So they're all as a fraction. When I have fractions, I try and get a common denominator. So I look at what is my common denominator for all of these three fractions, and the answer is 30. Okay, I'll start with the easiest one. How did I get from 1 to 30? I times by 30, so I need to also times the top by 30. How did I get from 6 to 30? I times by 5, so I also need to times the top by 5. So I have to times this by 5. 5 times 5 is 25. How did I get from 5 to 30? I times by 6. So I also need to times the top by 6. 3 times 6 is 18. That's my first step. Now I'm going to expand the brackets on the top. So when I expand the brackets over here, I get 25x plus 75 is equal to 120 plus 18x subtract 18. Now, they're all over 30, so look what happens if I times everything by 30. So the left-hand side by 30, and then everything on the right-hand side by 30. Our denominators disappear. Looks much easier, so now this is what we have. It's not written as a fraction. Okay, next step, right-hand side, I've got some like terms I can combine. So my left-hand side is still 25x plus 75, and combining my like terms over here, 120 subtract 18 is 102. Now what I need to do, I need to get anything with an x over to the left-hand side. So I'm going to subtract 18x here, because then they cancel. Remember, I need to do it to this side as well. So now combining some like terms on this side, 25x subtract 18x is 7x, and I've only got 102 over here. Okay, I don't want the 75 on the left-hand side, so subtract 75. Cancel. Remember to do it to the other side. So on my left-hand side I've got 7x, and on my right-hand side I have 27. If I divide this by 7, it cancels. So divide the other side by 7. So x is equal to 27 over 7. Let's look at our second example now. Okay, so here's our second example, and what I need to do is get a common denominator. So both of the denominators need a 3, both x minus 1, and then both are going to have an x plus 1. That's my common denominator. Now, what is on the bottom of the left-hand side here that wasn't here? And the answer is there is now an x plus 1. So what you need to do on the top, you need to also make sure that you add an x plus 1. So whatever I've added to the bottom here, I've added to the top. Let's look at our right-hand side. What is on the bottom here that was not above? Well, there's now a 3, and there's now an x minus 1. So what we need to do is on the top, we need to put a 3, and we need to put an x minus 1. So if you look there, I've colour-coded whatever we've put on the bottom, we also need to make sure that we've put on the top. So let's look what we have now. I'm going to expand brackets on the top. So on the left-hand side, I've got 4x plus 4 over 3x minus 1, x plus 1, And on the right hand side, I've got 3x. Subtract 3 over 3x minus 1, x plus 1. Now you would have got the drift from previous examples. If the denominators are the same, basically you can cancel them when they're on opposite sides of the equal sign. So if they've both got that, you can cancel them. So we now have 4x plus 4 is equal to 3x minus 3. Subtract 3, sorry. Let's subtract 3x here, because then that cancels, and it brings the x term over to the left-hand side, which is what we want. Got some like terms here that we can combine. 4x subtract 3x is 1x, plus 4 is equal to negative 3. If we subtract 4, that cancels, so we subtract 4. On the left-hand side, I'm left with 1x, or x, which is what I want, and then the left-hand side is negative 7.